Okay, properties of elements and their compounds can be related to the position of the elements in the periodic table. This is just information. It's not actually helping us at all. Explain. Explain is the command term. It means give description and a bit of a reason and a bit of background and a bit of detail. The decrease in atomic radius from sodium to chlorine. So from sodium to chlorine, what's the first thing I'm going to do? I'm going to find sodium, I'm going to find chlorine in the periodic table, and I'm going to figure out what their electronic configurations are. So sodium should be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. And chlorine should be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11, 12, 13, 14, 15, 16, 17 electrons. I don't need to stress and worry about the 1s2, s2p business for this one, because what we're looking at is the atomic radius, and so the circles actually help me a lot more in this situation. When you draw it out, you can see things. Never answer a question like this without drawing it out, because you start to make errors that you know are not true, but your mind gets messy because you're trying to do things under stress. The first thing that you'll see when you have this is that they have the same number of shells. That means that they have more or less the same amount of shielding. There isn't any additional shielding. Also, double check, are they ions or are they atoms? They are atoms. So what we're looking at here is, if chlorine, which has got more electrons, has got a decrease in atomic radius, so if this one is smaller and this one is bigger, despite the fact that this has more electrons, then we need to be thinking about attraction. So remember, what happens is the nucleus at the center pulls the electrons in. There is attraction between the nucleus and the outer shell. The outer shell for both of them being the exact same shell. So the only difference here that would increase the attraction is if I have an increase in the number of protons in the nucleus. So because I have more protons, I have a greater nuclear charge. Then that means that the electrons are pulled in here more tightly, even though there are more of them, than they are here. So because I have more protons in my nucleus, it causes a stronger pull on the outer electrons. It draws them in closer. Now, we have looked at this once before. This seems irrelevant, but it isn't. It's required. So even though is what they're looking for next. Even though they have the same number of shells, or even though they have the same amount of shielding. 1 mark, 2 marks.